Welcome back to Labyrinth Academy. I'm Madhulya Narat, your physics tutor. Today we are working on NATO Physics, Unit 6C1 Magnetic Fields. In this session, we will go through our checkpoint questions, 3 in total, to make sure you are confident with the key ideas. Here's the first one. The Earth acts as a giant bar magnet, and the geographic North Pole is at the magnetic south end of the field. Draw a sketch of the Earth with its magnetic field. For part A, I want you to draw a simple sketch of the Earth showing the magnetic field lines. Remember, the field lines come out of the magnetic north, which is near the geographic south pole, loop around the Earth and go back into the magnetic south, which is near the geographic north pole. Explain where you would expect the Earth's magnetic plus density to be the greatest. Now for part B. Magnetic plus density is a measure of how close the field lines are. The field is strongest where the lines are closest together on Earth. That happens at the poles. That's why compasses are more strongly aligned at the poles and less sensitive near the equator. Now let's move to question 2. In Britain, the Earth's magnetic plus density is 50,000 nanoteslas. With the field close to horizontal, estimate the plus passing through your body if you stand vertically and face north. We are told that in Britain, the Earth's magnetic plus density is about 50,000 nanoteslas and the field is close to horizontal. For part A, imagine standing upright, facing north. Your body presents a vertical area to the horizontal magnetic field. Let's approximate the area of your body as 1.7 meters tall and 0.5 meters wide. So about 0.85 square meters. Since the field is horizontal and your body area is vertical, the field passes straight through with an angle of 90 degree, meaning sine theta equals 1. So the plus is b times a equals 5.0 into 10 to the power minus 5 times 0.85, which gives about 4.3 into 10 to the power minus 5 Webers of plus passing through your body. A smartphone compass uses a 2 mm by 2 mm magnetometer chip. If the chip is at 20 degree to the horizontal, what plus passes through it? For part B, we switch to a smartphone. The magnetometer chip is just 2 mm by 2 mm. So the area is 4 into 10 to the power minus 6 square meters. Now, the chip is tilted 20 degree to the horizontal. So only the perpendicular component of the field counts. That means we multiply by sine 20 degree, which is about 0.34. So the plus is 5.0 into 10 to the power minus 5 times 4 into 10 to the power minus 6 times 0.34, which comes to about 6.8 into 10 to the power minus 11 Webers. This shows how even tiny sensors in a smartphone can detect the Earth's magnetic field very precisely. Finally, let's look at question 3, which link directly to applications like electric motors. In an electric motor, a permanent magnet of plus density 18.4 milliteslas has its field placed perpendicular to a coil of 250 turns of copper wire. The diameter of the coil is 8.50 centimeter. What is the plus linkage between the field and the coil? We have a permanent magnet producing a magnetic plus density of 18.4 milliteslas. The field is placed perpendicular to a coil with 250 turns of copper wire. The diameter of the coil is 8.50 centimeter. Step 1. Convert the units. The plus density is 18.4 milliteslas, which is 1.84 10 to the power minus 2 teslas. The radius of the coil is half the diameter. So 8.50 centimeter gives a radius of 0.0425 meters. Step 2. Find the area of one turn. The area is pi r square equals 5 times 0.0425 square, which works out to about 5.67 into 10 to the power minus 3 square meters. Step 3. Calculate the plus through one turn. Plus is b times a equals 1.84 into 10 to the power minus 2 times 5.67 into 10 to the power minus 3, giving about 1.04 into 10 to the power minus 4 Webers. Step 4. Calculate the plus linkage. With 250 turns, n pi equals 250 times 1.04 into 10 to the power minus 4, which is about 2.60 into 10 to the power minus 2 Weber turns. So the plus linkage between the field and the coil is 2.6 into 10 to the power minus 2 Weber turns. That brings us to end of our checkpoint questions for A2 Physics. Unit 6C1 on magnetic phase. We have seen how the Earth itself behaves like a giant magnet, how the plus rho and area can be calculated in real situations, from our own bodies to smartphone sensors, and finally how plus linkage is applied in devices such as electric motors. These questions show that the concept of plus density and plus linkage are not just abstract ideas but real, measurable quantities that connect directly to technology and the natural world. That's all for today's lesson. Next video, we'll explore the electric motor. If you found this video helpful, don't forget to like the video, subscribe, and check out other lessons and our educational documentaries. See you next time.